Hi, I would love to be shadowed and roasted. Please have a look at my Grasshopper file. Don't be polite. I don't need any encouragement. That's a very big mistake that I see a lot of time. Why do you have a flatten there? Doesn't make sense. So just remove it. That means this data tree should have been cleaned up way beforehand, way before all of these zeros appear there. But also here is weird how it's being used, because why? Why to have an expression 1? That just means basically you want 1 here and that's all. Why to add an extra graph there? That doesn't make sense. That doesn't make sense. And it's pretty impressive geometry. This model is amazing. Look at that. Hello everyone, welcome to another video. In today's video we will roast some Grasshopper models. We will learn from them. 2 weeks ago I did a post in LinkedIn in which I invited people to send me the Grasshopper models so that I could roast them and we could all together learn from them. In today's video I want to focus mainly on data tree structure, not in organizing the models or in optimization, since I got many models and then it's gonna become a very long video then. So yeah, let's get started. So first I wanted to show the post that I did 2 weeks ago, in which, well, there was a lot of reactions from it, so I'm glad that people like the idea. And then here we have some of the first people that sent me their models. So the first one that we have was Cameron. Cameron was the first one to send me some models. So here we have the list of people that sent them was 7. So he sent me this message. So basically their model creates a GFRC, glass fiber reinforced concrete fabrication part for a hotel in Denver, and it's pretty impressive geometry. So let's have a look at the Grasshopper file. So the first thing that I want to do is to check everything through this C# script. This C# script I did a long time ago, but it basically the idea was to automate the process of checking other people's Grasshopper files. So I want to keep a standard internally at ShapeDiver, and we collaborate with also freelancers externally, but also we have our own team internally, and we need to make sure that everyone is using the same rules regarding group coloring, organizing the model, but also to make sure that we can catch errors automatically. All of the errors that I have learned to catch, let's say, throughout the years, I just put them into this C# script, and now with that, I can quickly search for errors. I think here we will get mainly, because we're ignoring a lot of things, we're going to get mainly errors regarding data tree structure. So here we have the first error, which says several inputs in the component have different data tree structure. So let's have a look what that is. And is here this component where we have, you can see here the data tree structure is 0, 0, 0, and here we have 0, 3, 0. This is kind of correct, but I see already an issue here, that is this simplify. So we can see in this filter that some of the inputs have several items. So for example, this one has 3 items per branch. This one has 1 item per branch, and so on. And the one that we're getting right now is 1 item per branch, which give us this result. And then here, he's grafting and simplifying. Now, the problem of doing this is that actually the simplify is not doing anything. If we check the output of this, it's not going to be simplified. It's going to be exactly the same, in the sense that, here we have 0, 0. We graph that will give us 0, 0, 0. And with the simplify, we would expect just to get a single 0, but actually that doesn't happen. And the reason is because the simplify doesn't work if you don't have a comparison of paths. In this case, if we had multiple branches, if we had here 3 items and then we graphed, then we will have 0, 1, 0, 2, 0, 3. Then basically the simplify knows that the 0 is the repeating part, so you just delete those, and then you get just 0, 1, 2. I have an entire video that you can check in the channel where I talk all about this simplify and why you should avoid it at all costs. At ShapeDiver, we try to don't use it at all. But in this case, for example, I can show you. Let's see if we change this to one that has more than 1 item. So this one has 3 items. That's number 2. And here we can see the simplify did work. No, now we don't have 0, 0, 0, but we have 0, 1, 2. So it's clean. But the problem is that that's not the intention. So here what I would recommend is that instead of using the simplify, you use a shift path. So if I remove this simplify, then we could just shift by 2, then we get 0, 1, 2, and then we can send that. So now if we change again to the first one that was before, then we get there 0, which is probably the intention if you want to simplify. So after doing all of that cleanup, now we can see that we do get this 0, 0 here. So probably that, like this simplified that was not actually doing what was intended, was not making much of an issue. So it could be that the result would be the same, but my recommendation is to keep it clean so that you avoid other issues, because it could be that in the future you want to extend this to something else, it could bring more issues. So let's run this again and let's see which other errors do we get. Okay, here the error that I'm catching is because this data structure is different in 0 and in 1. So this is 15 branches, whereas this is 30 branches. Now this is a filter, so it could be that that's okay. But I can see here that there is something strange happening where we have a path mapper with AB changing to BA, and I don't know if that's really necessary. And then with a flip, that flip could have been done maybe beforehand with this path mapper. And we have a simplify again, so that's not good. So I always try to check the source of the path change. So basically, to keep my data trees clean, I need to see where they are changing. So for example, here I know that this component always outputs an extra 0. So if I do this, that will add an extra 0. We have as an input just 0, 0, and then here as an output we have an extra 0. Any component that where the output says list, so here you say the output is called list and is a list, then any component that the output is a list, then you will always get an extra 0 there. And then you have to decide whether you actually need that extra 0 or not. Based on what I see here, you really don't need it, and you could get rid of it. Now here we have a flatten there, and if we go back, that's coming from here, which is an internalized thing, which is already 0. So that's not really needed there. Again, like nothing that changes, like you will end up with the same, but if you want to extend your models in the future, like just try to keep your data structure clear and intentional. Why do you have a flatten there? Doesn't make sense. So just remove it. Then let's continue. So this one will add an additional 0 there. And then the intention was basically just to flip it up. But let's just see what was the intention before. So you have 0, 1, and 0, 0. Then you just flip it up. That really doesn't make any difference unless the inputs change something. But no, because the input is just this and that. That's internalized. So unless something here is missing that I don't know about, I think here the only thing that you are meaning to do is to do this, to just flip it up. Yeah, and you get exactly the same. So even if I just remove that simplify and I flip it, I will get those extra zeros there that I don't want, but that's all what I want anyways. So my recommendation here would be remove that because you don't really need it. You just need to flip, and then if you want to clean it up, then what I would do is just do a trim here by 2, because I know I get 1 0 here and another 0 here extra. So we just cleaned it up. And then here, this flatten and graph, that's okay, but I would recommend using this component instead, which is called renumber path. So in that case, I would just flatten here, and then that will just renumber the paths for me. Now here, as you can see, I am removing that extra 0 as well, which I wonder whether you even need it here as well. So I would also get rid of it here. And that seems to still work okay. What is happening is mainly cleaning the data tree. So first of all, the mapping of it, how it was being changed, there was components that were being used that were too complex for the actual purpose of it. If we know that these zeros are really not needed, then just get rid of them. Get rid of them intentionally. Not with a simplify, but intentionally knowing, okay, I know here I get a 0, I know here I get a 0. Then I remove those 2 zeros because I know I don't need them. Not because the simplify does it for me, because then you will get issues where the simplified doesn't work as you expect. Then I see here another thing. Well, that's weird. Why do we have an expression that is 1? Because an expression that is 1 means this is 1. So we have an internalization of 0, because that means my data internalized is 0, but my expression is 1. So I recommend to completely avoid expressions to begin with, because they are slow. But also here is weird how it's being used, because why? Why to have an expression 1? Because that just means basically you want 1 here, and that's all. So I would just do that and remove completely that expression. Okay. And now here it seems you are looking is for the amount of paths. What I would have done is, instead of that, I would have used 𝘃statistics. And this one already gives me the count, the amount of paths that I want. So when we go a bit more direct in how we check our data tree structure. We have here this other participant. Hi, I would love to be shattered and roasted. Please have a look at my Grasshopper file. I did this in 2020 for a competition. Don't be polite. I don't need any encouragement or sympathy. I need to learn from my mistakes. Cool. Cool message. Thank you very much for participating. This model is amazing. Look at that. Wow. I was very impressed when I look at this model. I don't know if it's impressive the view. I don't know if it's impressive the Grasshopper file, but how it looks, the final result is pretty cool. Let's check the first error. Structure is not matching. Here we have 13 branches, and here we have 12 branches. This seems to be a display, so it's at the complete end of the script. So it could be that it doesn't matter, but probably that was not the intention. Most probably here what is happening is that the last branch is using the number 10. But yeah, I would recommend to look at that and see why that is mismatching. Let's go for the next one. Yeah, that's a very big mistake that I see a lot of time. So it's half okay. So the problem here is that D1 is not matching with D2. So in one end, he's grafting, and in the other end, he's flattening. Now, I don't know why he's flattening here. Doesn't seem like it makes sense. It seems to me that is because of this, because I think he had a confusion here with this one. This is a component that also gives us a list as an output, so it's going to give us an extra 0 there. So we just need to clean it up. So what I would do is I would flatten graft instead there, but I will lock the solver. Otherwise, maybe I will make this explode. So I will graft here. I wouldn't flatten there, but I would trim instead. Now, if we already have grafted there, we don't really need to graft there anymore. And here we are just cleaning it up. Now that means this data structure will be the same. We love. This creates just one item as an output, and this creates just one item as an output. And you already know that here is just one single item because we are grafting. So this grafting here doesn't really make sense. Why to add an extra graph there? That doesn't make sense. That doesn't make sense, because that's going to give us already one item. None of these ones should create an extra 0. And then when we do the merge, this will match. So let's have a look. Okay, this data tree structure is anyways different. Now here, I don't think this graph makes sense either, because this polyline will give us a one item per branch anyways. So I would remove that. And here we do get multiple items, so that graph makes sense. So actually these two don't match. They are different. They create a different data structure. We can see it here. We did clean it up a bit because there were some graphs that didn't make sense. There were some flattens that didn't make sense. So it's again a matter of where does it make sense to put a flatten? Where does it make sense to put a graph? Again, so that we are intentional, so that when somebody external like me or like your colleagues or you yourself in 10 years need to review this file, you understand the intention of each of the decisions that you took, no? Like, why did you flatten? Why did you graph? Now here, the last part is still not solved, but that I will solve in a different way. And that's because that anyways goes afterwards into an end one, and this end one is flattening everything here anyways. So unless the order of this is needed in a specific way, if it's not, then I could either flatten at the exit or flatten in the input. And then if we know, okay, here I know my paths are not needed to match, they don't need to match, then just flatten them, so that this script won't catch them, and then we can catch maybe other issues that are really there. Let's check this next one. Okay, here we have a similar situation with a merge where the inputs don't match. Now, if we check that, if we wouldn't to flatten, then we get this result. Now we get two branches. This could be confusing again if you really need a specific order of your list. If you need a specific order of your list, just entering the inputs like that doesn't mean D1 is going to go first and D2 is going to go first. Because if this data tree structure is different, then this could be flipped potentially. In this case, no, because accidentally the data tree structure makes it so that the output has the same order. But what I recommend is, if this order is important, is to flatten at the start of the merge instead of the output. And then in that way, we know we will for sure get first D1 and then D2. Now let's continue. Similar issue, you should flatten at the start. Similar issue, we have again branches in different path structures. Now they go into an endpoint, so they are eventually flattened, but we could flatten them from the start. Okay, we have a branch 4, and then we have a graph there. So first of all, this graph doesn't make sense there unless this number can change. Here you are getting just a single item, which means this graph makes no difference. So I would just remove that. And second, the reason why this is catching it is because we have here branch number 4. So of course we get here a different structure. Now we have in one end 0 and in the other one 4, but it should be okay anyways. That should work anyways. Let's go for the next issue. Same situation with the merge. He always flattens at the end, but yeah, if you really care about that order, then you should try to flatten at the start of the merge. Or in this case, I would even recommend not flatten, but for example, here, the only thing, well, yeah, here there is many zeros, but that means this data tree should have been cleaned up way beforehand, way before all of these zeros appear there.
And that's all for today. Unfortunately, I could just roast 2 models. To be able to review all of these models and to give real value, it takes time. So I have decided to divide this into 2 parts. In this part, I review 2 models. In the second part, I will review another 2 models and focus mainly in data structure for now, in data tree structure for now. So I hope you learned something new from this video. And if you want your models to get roasted as well, then please send it to me. And then based on the amount of interest there is, then I may do more and more of these kind of videos in the future. So thank you very much for watching, and see you in the next one.